got me alive, but got no alibi. It's a rebel's fight without an alibi. Took my innocence without an alibi.
Alright, hello everybody who happens to be in the channel at the moment. Welcome if you're watching this on the recording. I am back to continue my daily streaming of binary exploitation ponables practice. We left off yesterday with an unfinished challenge. Kept thinking I was just moments away from finishing it, and then right at the last, when I seem to have gotten the actual ROP chain working and attempting to spawn a shell, at least, we got a abort signal from who knows where. That's the main thing we're gonna work on starting off, I think. I had to restart my computer, so I've lost all of the context where I was at, but we are going to look for I should turn off those notifications maybe. We're going to look for the source of the abort signal. Something tells me the other functions that I noticed with GDB that are in this binary are connected to that. This is purely based on the fact that so far the challenge has been pretty straightforward compared to the previous dynamic challenges of just creating creating a ROP chain that calls the either one gadget or calls system with bin/sh and all that directly. The stuff that we've been doing in the last 2 or 3 streams. This one seemed like a really straightforward version of that, and I don't know why it would be placed last in the list if it was just that simple. It's entirely possible that that's really how it worked out, and they just sort of threw it in at the end and weren't thinking about it in terms of making the challenges more difficult each time. But I'm sort of betting on the fact that there were more functions in there, and I never looked at them never needed to see them to figure out how to get the overflow going. Just makes me think that there's additional layers to this challenge. So that's where I am headed first, is gonna pop it open in GDB, and we will start by disassembling those functions. One thing that I noticed is if I say if I open this with Pwn Tools as a ELF binary, I say binary.plt and binary.symbols. We get a bunch of symbols that are, the stuff from the CRT, what gets added in by libc, or technically by the compiler, but is, sort of related to libc kind of stuff, _start, etc., the initializers. But in the PLT, we only have 3 functions that are basically imported into this binary from libc or from anywhere at all, and none of them are calling anything related to signals. There's no abort call in here or anything of that nature. So I'm wondering if the program is literally sending an abort signal, then maybe it's doing it directly with a system call, and that should be relatively obvious if we can find that. Find one of these 3 functions, like beginning, there's a middle in here, an end, and a climax function. Here's the end one. Middle, yeah. So in one of those functions, maybe they're directly doing a syscall, and we can hone in on that and see what syscall they're doing, and maybe figure out a way to prevent it if that's necessary. But right now I don't actually know just, kind of what the heck is going on. So if we run our exploit, it is about to start doing the exploit, but I've hit on the suggestion of a gentleman in chat, Julian, yesterday, I put a pause in there so that I can attach to it with GDB, which has been really helpful. So I'm going to do that right now, and we are paused in the main function on the read call because it's just waiting for the input that we haven't yet supplied. Or right now it's like broken in the debugger because I just attached, but it was paused in the pwn tool script, not yet sending input to the process that it spawned. Okay, so I'm not going to put any breakpoints on. I'm just going to hit continue. Still going to wait for input until I unpause on this side, and then we should see it get the abort signal in GDB. And we definitely do. And the call stack for this does not come from any of those functions like beginning, middle, end, or anything. But I'm thinking exec.com child. I wonder if that is. Oops. Let's see. I quit out of that because ultimately the program was just going to end. I don't think I'm going to find anything in the man page, but so presumably, okay, interesting. First thing is for a exploit content, like discussion of an article about exploiting a heap vulnerability. I'm gonna do a Google search. Sometimes I find Google to be a little more helpful with these word exp. What is, why would, I mean, I don't know what word exp is, word exp, but am I misinterpreting this as being word exp? I don't know. It just doesn't make a lot of sense to me what that means. We've got some code in uclibc. Oh yeah, Warbach. I need to remember that name as the a nice searching tool for glibc and a couple other libraries, like web browsing of the code. But so this is about parsing certain stuff from strings. It's definitely like oops. Okay. What is exec.com, I guess. But like, why is it in here? Why would this stuff be? I don't know what exec.com is, I guess. That's, well, okay, fair enough. Need to maybe quote that. Doesn't help. I could just search for it in the Wabach thing, I guess. Just 3 matches. Let's search for just exec.com. Nope, just the one in this file. Oops. It's the same file, so I don't. Oh, why? Oh, because there's a space. I put execcomm open paren. Okay. Function to execute a command and retrieve the results. Okay, I see. Command. Okay. I was thinking like communication or something. What calls execute command like this? Parse backtick? So this is on the shell? Why would we be... Oh, I can just hover over it, right? But we can see from the call stack, we got into... What is word then? Not helpful. Maybe it's not. So, what? Okay, I don't know. Just like truly don't understand what's going on here. So we could certainly, I guess I could download maybe the glibc source and stuff and maybe get better debugging on this stuff. But let's see, we call abort in execcomm child. So let's at least see why we are getting, and that's just called from execcomm, why we're getting abort. Okay. So, I mean, maybe this is genuinely what we are okay. So I guess what this might be, why we might be getting this is I thought that we were in like do system. I had assumed that this was where we end up calling the exec ve syscall to spawn the shell and all of that. But maybe it actually, it calls POSIX spawn. Okay. Which, so let's just go to the definition of that. Oops. And I guess we'll look at the Linux one. Okay. Then we've got spawn nix. or spawn IX rather, which map some stuff to make the stack, then calls clone. Clone being, presumably this is making the clone syscall actually. Okay. Yeah, because it's not going to necessarily do execve directly. What is... I don't know what this would be about. Okay, so... Oh, that's all in a different function anyways. I don't know what this function is about. Spawn child. For some reason I was assuming that the one gadget stuff was coming from I have oh, you know, that's an interesting thing that maybe I need to look into. Okay. So I was assuming that the one gadget stuff was actually running, like jumping into the middle of the do system implementation function for the system library call, but it doesn't seem like that's the case because this goes through, this doesn't even use the execve syscall. It uses the clone syscall because it's going to spawn a new process. Well, I guess execve would as well, but in any case, it seems like this is not how things are being done. So I need to look at what happens with the remainder of our gadget, basically, or like what happens when we actually get into the one gadget. So I'm going to put a breakpoint on main on the return, and then we can run the exploit again. We get to the return for the first time. This is where we're leaking stuff. So we'll just continue. And now we're going to the shellcode popping the shell rob chain. So we get the shell properly aligned, and then yeah, we're popping into execcom. Okay. So my guess is that by the time we do execve, RSP plus 70 is no longer null. Like we're not hitting the constraint that we need for this particular gadget. Oh, because I have popped stuff to align the stack, maybe? Ooh, okay. Need to think about that more then. Let's see. We just moved that into RSI. Yeah, so that is not null. Okay. And it's not pointing to a string that is helpful for us. So then RDI points at bin/sh. And okay, RDX has the environment. So let's look at forget how I'm supposed to do this. I don't want to display it as a string though, I just want to print that memory. I like examine memory. Unable to display strings with size. I don't want to display a string. Do I need to say ZG? Okay. All right. So what about 40? Okay. Oh. Well, that's pretty simple then. We just need to switch the gadget to the one gadget that has the constraint that RSP plus 40 hex is null. Because even though our original version 70 plus 70 hex was null, we had to modify the stack pointer in order to get proper alignment so that one of the move APS calls didn't result in a seg fault, and thus plus 70 hex is no longer null, but conveniently plus 40 hex is null, so we can still use one gadget. So that should be pretty straightforward fix. We are going to use this gadget instead. Nope. Let's say, oops. Okay, then, and that worked. Great. So we were, if I didn't have to go through this whole process of trying to understand what the heck exec.com was and where the abort was coming from and all that, you know, we were mere moments away from getting it working at the end of the last stream. Well, that feels good that I wasn't so completely off, and it turns out that whatever those other functions were didn't come into play with how I went about it. I guess I'll quickly read through the walkthrough on this one. Maybe they will explain what those other functions were. Maybe. So the technique that I used in this was we need to leak an address. So we are leaking the address of the write call that is imported from libc by using the write function to write out the address that is stored in the global offset table for the write entry. We could have, I guess, had it write out the address for the read entry or something, but basically I stole this from the previous write-up. I think it was maybe this one. Yeah, where their version was with puts because that's what was used in that binary, and they went through. They also used one gadget here. Interesting. Oh, this is not the one that I was reading through, but they went with the same approach that I did on that one as well. This one was mostly about converting a whatchamacallit. There is a UF. Wow, that would have saved me a little bit. So this was just about like providing the input as strings that could be parsed as a floating point value, and when they are parsed, they give you the right bit pattern for whatever instructions or addresses you need to put into memory. I think it was this one, maybe, where they were using the puts global offset table, and that's like I hadn't thought about that technique before, so I decided to leverage it again for this challenge. and it worked wonderfully. Other than needing to use write instead of puts. So the other aspect of what they did, because going through and actually getting that leak requires us to overwrite the buffer to the point where we're getting control over the return pointer so that we can do a ROP chain. But if we have written the ROP chain before we know what the base address of libc is, we can't then include the gadget address in that ROP chain. So we have to do two ROP chains basically, and the first one ends by returning to the beginning of the main function so that it goes through the process again and writes or calls read again, rather, to read into the buffer that we then overflow a second time with our ROP chain, and this time we can write the correct stuff into it because we know we've leaked the info that we need to calculate the right address for the gadget. So it's possible. So my reason for going over all of this again is that it is possible that the other functions in this binary were about giving you that opportunity to do a second ROP chain if you didn't think of like returning to the beginning of the main function or something. And we don't even really have to return to the beginning of the main function. We probably could have returned to the start of the setup for the read call or something and skipped the repeated write calls, but it's kind of six of one, half dozen of the other kind of thing. So maybe this walkthrough will discuss what those other functions are. They aren't called according to the C source code here, though, so that is interesting that they exist at all. Maybe there's additional challenges in those functions. I guess I can do just a quick analysis. Say, so this one is writing out a string, nothing interesting there. Okay, another writing out a string. This one reads. So maybe maybe they had created a slightly more involved version of the challenge originally that split it up into multiple functions. And then at some point in the development of the challenge, they decided, let's just do it all in the main function and make it a very straightforward thing. And they just took out the calls to these other functions, because the climax is where we do the read, and then and end has another write in it. I assume that climax comes before end. I think that's usually how the structure of like the end being like the denouement or whatever it's called in a story. But the main function does not call those functions at all. So yeah, they're just sort of sitting in the binary not being used as far as I can tell, and that's fine. Okay, I'm gonna just quickly browse through this. Do. Oh, okay. So in their version of the exploit, they made use of those functions that aren't being called but are sitting in there. So they called into the end function but at whatever point after the string parameter has been loaded and instead popped their own string parameter as the second one. So that simplifies a little bit because they've already put the 1 in the right register, or they will afterwards, or one or the other, and then the length is going to be enough. So that's fine, and then they reuse the read call they use the read call from climax. So instead of returning to the main function, working through that whole thing again, they use this one, which is just, buffer overflow as a function. Basically, you got a 48 byte buffer, and then you're going to read 4,000 bytes into it so you can do whatever overflow you want. I guess if we needed a really long ROP chain, if we didn't have this cool one gadget tool and we needed to write a long ROP chain for some reason, this would be the way to go because the overflow is so large. But yeah, basically doing the same thing, and that, feels good to me. Okay, so we're going to move on to the next challenge, or the next category of challenges, which are format string issues. In particular, I believe these maybe all stem from, there's two things that I think you could use format string logic for in doing exploitation. Why is there no 09? Missed that. Let me go see the Git repo. There is. It's just been reorganized. So the bad seed stuff comes down here. And this is 09. Okay, whatever. So the two ways that I can think of right now for making use of format string stuff is you could change a format string that maybe it's supposed to print %s and then have a string parameter, but you do %p, and now you're printing out the pointer to that string, or the pointer that string is. That, you know what I'm saying, I think. And that point, you've got an info leak about address for, maybe it's stored on the stack, maybe it's stored on the heap somewhere, maybe it's in fixed data and that's helpful to you somehow, but you are hopefully leaking info that you can then use to mitigate ASLR stuff or, related techniques for randomizing memory addresses. And then the other one is just sort of any use of the %n. When you can control I'm not sure that anytime you use %n it's a vulnerability, but I think if the attacker can control the other stuff that gets written, so if you have maybe a %s and then a %n, for example, the %s, if the string that gets printed with that is controlled by the attacker, they can potentially, if they have control over the length of that string, then they have control over what gets put in the %n and like what number gets written to whatever parameter from the %n. There's potential vulnerabilities from that. I think the more likely vulnerability comes from somehow the attacker can control the contents of the format string in the same way that maybe you could do an info leak, you could do a write with %n, because if you are printing something and you don't have a parameter, or even if you have parameters, but you could have those parameters consumed by previous %format, like format specifiers, and then the %n is going to be the size of how much you've already written, and it's going to be written to a location that was not intended to be written to at all, so you've got a memory corruption from there. And you can, it's not the same as a buffer overflow in the sense that you aren't having to write an entire buffer. So with very careful positioning, you could just write to the return pointer location on the stack. And in that way, I think you would be skipping any stack canary mitigations because you're not writing from before the stack canary all the way through it. You are just writing directly to the return pointer address. And that's because you are basically telling printf to read all of the memory before that, but it's not writing to it. You're using a format specifier that simply reads those values. So this is what I remember from live, let's see, format string maybe. Yeah, I think it was this one that I was watching, but he's probably got some other ones at this point. And John Hammond's got a video on format string vulnerability. So these are, oh, and he's got another one that, wow, he uses it to override the global offset table, which is pretty interesting because I feel like printf is going to be starting with, it's going to be like accessing either for read or write addresses that are on the stack. So the global offset table is in theory relatively far away from the stack, that, like, especially on a 64-bit. So maybe this would only work on 32-bit, but you would have to print so much to have printf read all the way to the global offset table, I would think. But definitely a video that I'd like to watch and figure out a little more about what's going on there. But he's also got, I don't know, 3 or 4 other ones in addition. So quite a few videos that involve using format string exploits for different CTF challenges, it looks like. So that's cool. If you haven't looked at his channel, I would highly recommend it. He puts a lot of work into his videos and making them very instructional and entertaining and just like a lot clearer than you would get from not putting in all that work, I guess. As you know, anybody that makes videos, either just streaming or creating, instructional videos, would be able to tell you that the level of work that he puts in is impressive, let's say. Okay, so yeah, I think we could probably just go for it. This is the sort where, oh, the other thing that I wanted to mention, there was just like Mazda. Let me just search for it on my GitHub. Just to sort of, oh, there it is. Give myself some props. The thing that sort of got me thinking about this concept a lot more is last year, a little ways more than a year ago, I think. Yeah, 14 months ago. There was an episode of a podcast. I guess I don't mention it in here anywhere, but the podcast is called, why am I blanking on it right now? Reply All. And They have, yeah. So reply all is a interesting little, like, not super technical, certainly from the standpoint of the kinds of stuff that we're working on here. And if you're into like hacking and stuff, it's not going to come across as particularly technical, but it's sort of just generally about internet topics. And they have a few episodes where they get a little more technical than they normally do in this series called Super Tech Support, where somebody sends them an email or a recorded message about a problem that they're having, and they pick one that sounds really weird and interesting to investigate, and then they take a lot of time investigating it to figure out if they can understand what's going wrong. In this one, and their investigations are more like journalistic investigations than maybe programmer debugging, hacker investigation kind of stuff. So in this one, somebody was trying to play a particular podcast on their in their 2016 Mazda sedan, and that podcast name is 99% Invisible, and they couldn't come up with, like, it didn't make any sense why it would cause their car infotainment system to crash. And it they went through a lot of potential solutions. They actually did hit upon the idea of the percent symbol being part of it, the potentially the printf thing. It's fun to listen to, so I would suggest, like, just, especially if you kind of understand what the vulnerability or what the bug actually is. Hearing them go through all these different ways of basically not getting to that is pretty entertaining. They make it a very entertaining process, and they like generate a bunch of other podcasts with weird symbols in the names to try to see if those trigger any problems. And then you get to listen to their weird podcasts, which are, I guess, all of these, like one that's just with a tilde. And then they eventually realize, oh, maybe it's the percent in there, but they weren't able to get it to trigger. And basically, they never, I think, got to the point where they realized it with the percent %n. The space and the I are part of the format specifier, and I go into that in my blog or in my GitHub page. But it's definitely the percent %n that's causing it, because you're getting a write to some memory that shouldn't be written to, and then you get the crash from that. And unfortunately, eventually they talked to one of the people that developed for the infotainment system, and this person claimed that they didn't even use C code in developing it. It was all JavaScript, so there's no way that could have been the vulnerability. So they just sort of go, okay, I guess it was something else, which is really unfortunate from my standpoint, because, like, it's very clear. And in fact, I don't have it anywhere in this GitHub repo, but somebody on Twitter did some digging and found, like, the firmware dump that you can for doing an upgrade to your system, and I opened that up and investigated and found what was likely the binary that was that had this in it. It looked like they were probably doing an sprintf into a thing that then got passed to printf. And so when you got the percent format specifier in the thing that got eventually passed to printf, that's how it comes out, basically. But if you are curious about the details of that, you can go to my GitHub page and look at the Mazda format string bug, where I really lay out in extreme detail exactly why that podcast name does include a format specifier that would be accepted by Clang and GCC, even though it's using stuff from Windows, and this was entirely a Linux binary running on a Linux embedded system. For compatibility reasons, the compilers, both of those compilers, as far as I can tell, support the Microsoft non-standard format specifier things, basically, and that's what allows this to happen. I mean, what allows it to happen is the fact that they eventually get user-controlled or untrusted string info into their printf call and in the format parameter. So that's the thing that should be fixed, I guess. But setting that aside, yeah, I don't know if you want to see that, but that's sort of what got me looking at this kind of stuff in the first place. Because I don't know that I had it. Like I think I had heard about format string vulnerabilities before, but I hadn't really learned about the details and hadn't had any to deal with in a CTF challenge. So now I get to try to actually exploit it, because I didn't do any real exploit in that GitHub repo that I just showed. I just got it to crash and I think if I were to go back to it and look at the code right now, I think I would say the way that I got it to crash was probably not even particularly accurate to what was happening on their system in the Mazda, but it was enough to show that when you put in the name 99% invisible, the program dies, and when you put in 99 without the percent, and then it doesn't. So okay, all of that aside, let us look at this BB Pwn, which may be Baby Pwn. So this one we are probably, I need a copy in the file. Probably gonna have to use radar to, what is it, backdoor? Where's the file? 32 new? Okay, that's the one, I guess. 32-bit. We probably need to reverse it so that I can see where the printf call is happening and figure out if we can control the format specifier string, that kind of stuff. Because with the previous challenge, I never even opened it with radar in getting the thing to work, because we were just overflowing the only input that we were getting, the only potential input to the program. So that was really relatively straightforward. I don't think it'll be as obvious what is exploitable with a format string bug just by sending some questionable input, let's say. Okay, let's check the security on it, because why not? No canary, NX is enabled, no PIE. So if we are writing, if the exploit that we have, the vulnerability that we have available to us is we can write to arbitrary memory, then we'll still need to write a ROP chain, it looks like. Okay. And I guess let's run it. Ooh, okay. I need to install the 32-bit version of libstandard C++. Let's see if it's the same as from 1604. Did I have to do this on a previous one? Let's try this, because I feel like I did this instruction already, but maybe it was on a different virtual machine. Yeah. Okay. I guess I had libc6, yeah, but not the C++ one. Okay. Okay. Okay, so, I mean, obviously we can see the format string vulnerability there. And I think if I just put %n first, then it's a 0 that gets written. So let's open it in radar. fgets to get that string. I call sn printf. Oh, I see. Okay, and then put our string. Yeah, you have to go through a few hoops, I guess, to get to the point where you are printing a user supplied string as the parameter to printf. So our %n actually goes here, and so it's not writing a 0. It's going to write at least this number to the first time that it does a write. We could maybe have that write go somewhere that we don't care about, and then it'll be maybe easier to control the number that we do write to, I don't know, the exit. Okay. Oh, and it calls exit. Does not call return. What are the imported symbols? It does import system. Interesting. Where does it import? Like, where does it call system? Oh, there's a flag function. Okay, so this will be a more straightforward one. Pretty sure the flag function probably calls cat flag. Yeah. Okay. So we'll throw in our flag.txt. That's why there was a flag.txt in wherever it was in here. Okay, so we just need to. It's a good question. How are we going to? Oops, that's not what I wanted to do. How are we going to move the control flow to get us to the flag function? We can't just override the return pointer. There is no return. So we could do what I saw was mentioned and brought it up in one of those live overflow video titles that was about overriding the global offset table. I guess that's what we will do. That's the most obvious thing from my point of view. Although we might want to do it with flush instead of exit. The reason for that is we've already called flush. So the work of the PLT stub where it loads the address, does the like lazy binding kind of thing, and then puts the address in, that will have already happened for flush. So we can just override that address, and when we call the PLT stub, it goes directly to whatever address we put in there. Whereas with exit, it won't. I mean, I guess we could just write the address that in the proper place. So then when exit calls, it's like it had already worked that out. And yeah, that's probably fine. And it pushes 1, and I'm guessing flag doesn't care. Yeah, so we should be able to do it with exit, I guess. I suppose there's not any particular reason to not do it with exit. I need to figure out what the global offset table structure is, and then we'll figure out where it's located. And then we need to calculate how we get there from where we're at on the stack. Of course, is this a scenario where we need to leak a stack pointer first? Oh, that's... So, if we need to read far enough from wherever printf is going to be looking for its parameters, which is on the stack, and such that it reads all the way down into the global offset table, and then we can do the write to there. My worry is that the offset between the global offset table location that we need to write to and like the first parameter on the stack that printf is going to read from, if we put in a percent whatever, that those addresses are, it's not a fixed offset between them. There's not a fixed distance, because the stack is going to be randomly located on each execution, in which case we need to leak a stack address, and I don't see how we can... I mean, we can leak the stack address by supplying just like a %p or something, pretty sure. Right, so we leak an address. Oh, it's the same address every time though, so it has no PIE, but I should have what is it, proc sys kernel randomize. That is on, so I would have thought even with no PIE, the stack location would be randomized, but I guess not. Or this is a fixed address. Let's see. Let's do like several %p's. So these are probably stack addresses. And these are different each time. Yeah. Okay. Or at least some of them are. Something to consider. I do like %f space. What does that look like? Okay. So the first one is the address of this string. Fine. And then we've got these addresses. Which are, some of them are different every time. How do we get right to what we need to write to? And is it definitely the case that this function has no return path? Let's check it out in GDB. And yeah, there's no return. Okay, just wanted to double check what I'm seeing in radar in case, you know, these tools are not necessarily perfect. So yeah, we need to get the PLT entry, or really the GOT entry overwritten for, let's say, exit, which is at a fixed address. We know that, but how do we get there? I guess I could watch the Stack Overflow video and see what he's done. That hasn't been my style for these streams before, is like doing the learning process on stream versus just sort of trying to practice what I've learned outside of the stream or have done previously. But I can't think of any obvious, like, let's do just a wild number of % p values. And then eventually it gets to, like, it doesn't let us do 1024, huh? Interesting. And some of these are the well, after a certain point, is it printing out the same stuff? It's got 70, 25, 20, 70, 20, 70. Let's do hex. What is the specifiers? I don't remember the syntax for like a single byte. Single character, but I want to do we have unsigned char? Okay. So if I do HH, that is of course assuming this was compiled with C++11, seems unlikely, but we can give it a shot. Hey, that works. Okay. Of course, it's reading just the 1 byte out of those things, out of each 8 bytes of memory. Okay. Oh, done something wrong. Oh, okay. Terminal got messed up by that. It was just, yeah, I don't know what's going on once we get past a certain amount and we're just seeing the same stuff, the same bytes sort of repeated in what might be the same exact order. Yeah, it's like 25, 70, 20, 25, 7020. Which is what? Oh, it's our. Yeah, okay, that makes sense. Could have worked that one out maybe, but okay, so we I might have to review the Stack Overflow video or look up some stuff about what the best way to do these specifiers is. Like, if I need to, I was just hoping to get like a full listing of a whole bunch of memory, and then I could start to try to suss out what was at those memory locations, but doesn't look like that's going to be possible. I wonder, maybe this is limited because we only accept a certain length for fgets. That probably is what's going on. And is that, yeah, and it's the right length for that buffer. Okay, so the buffer is 192 characters long. So like if we take out the space, we get a few more in there at least, but it just becomes harder to see. Actually, we get even less meaningful stuff, I think, because we've still got a lot of our strings in the buffer. So we need to first go beyond our stuff, which is like how do we I'm gonna just go through this real quick, see what he's got written. Yeah, so he's got the same kind of vulnerability where they've just got the exit there and they need to override the just going to talk about the PLT for a while or go offset table. Okay, let's see. Hmm. Hmm. My main concern thus far in looking through the video, just sort of like maybe there's a more straightforward way than getting certain value in there. Oh, is there? Okay, I think maybe the thing that we. Right. We don't need to sort of get printf to read a whole bunch of locations starting from the stack going forward. It's going to take a value off of the stack and use that as the pointer to the location to write to when you do %n. Because you would, like, I don't know, allocate an integer on the stack and then pass a reference, or, you know, sort of ampersand, whatever that variable is if you're writing C code. And so you give printf the pointer, so it's looking for that pointer on the stack at a certain location, and then it will print what you need. It'll write there however many bytes. So, like, however many bytes it has written, that's the %n mechanic. So we don't need to worry about the distance between the stack and the goal offset table. We just need to get the goal offset table address, and then we're fine. Okay, so should be able to do this. Can I do it in an hour? Let's find out. I don't know. My brain is being like, oh, I don't want to do this, but that's, you know, this is what I've signed up for. So can we find what is relocation exit? I guess I can just get it from Pwn Tools, the address of that GOT entry. Yeah, that's fine. Okay. So then we obviously need to work out how to know which stack address is the one that it will be working from. My guess is it's going to just be the first thing on the stack. If %n is the first specifier in the string. So we can give that a shot. We would need to get that. Okay, right. So what we need to do is put the address into our format string, and then do enough stuff in terms of format specifiers to get it aligned so that when printf is looking on the stack for, it's looking however many bytes down the stack for the pointer to use for %n, then it happens to be hitting on the address that we put into the string at the beginning. So looking at this, we have 8 bytes, or 4 bytes, 8 bytes, 16 bytes, 12 bytes, 16 bytes, 20 bytes, 24, 28, 32, 36, 40, and that's the beginning of our string. So after 40, so we could do 10% x, I guess. Then the next one is going to write to a particular address. Let's see if that works. So let's say we don't put null bytes, because I think it's just gonna quit out of that immediately, or the printf is going to see that as the end of the string and not print anything. So we'll put 01, 01, 01, 01. Probably should segfault if we try to write to this address. And then do %x. Let's do that plus %x10. Sorry, %x times 10 plus %n. Okay, so we got a segfault from that, and then dmessage says got a segfault. Doesn't tell us where it was trying to write to. Can we? Oops! Oh no! Fucked it up. Okay. Map error. This was the address that it was writing to. Not. So maybe too many? Because that's going to be like %x or something. Yeah, okay. So if we do 9%, so we have 9 D words that we read off of the stack. And then we want to write to a particular address. And we'll get that address with Pwn tools. And then we need to put in, we'll do 8, and then we'll do one that's like a spacer to get the right amount written to that address. Okay. Let's see. Then we need exit PLT, or no, GOT. Okay. Then our payload is going to be start with that. And we will add on %x times 8 encoded as bytes. We will add on %100x. We'll just do this for right now. It's not going to help us, or it's not going to be right. I guess that's the way to do it. Okay, and but we can, I think the idea with this is we will see where the exit call attempted to jump to, and if it's like it'll be like 119 or something, and so we will work out the difference between the flag address and the amount that we actually have written here, and that should be how we know what number to put into there, basically. Okay, so target.receive until, I think just new line, and send the payload. Right, if we just run, yeah, okay. Key error flag. Could have sworn it said it had a flag. Function sim.flag. Is that maybe named based on the string that's in there and it's not actually a function name? We just throw in the hard-coded address. I don't know why I'm spending so much time deciding to look through all of this nonsense. Or is it possibly called something else because it's like written with C++, and so it's a mangled name of some kind? Don't think this is going to help me to read it this way. I guess I will just put in the hard-coded address, even though it seems like it should be possible to have it in the symbols. Maybe we simply don't have that symbol. I'm just sort of vamping as I finish reading through this. Yeah, I'm not seeing it, so interesting. Maybe, I mean, I know that radar will put names on the functions when you do the AAA at least, and it guesses those names a lot of times from the strings that are mentioned in it, which works out pretty well in the case of a function that mentions flag.txt, and I think it just, there might even be some special coding that's like, oh, if the string includes the term flag, then name the function flag or something, like very obvious in that way, because this gets used a lot for how to put it. Why don't we, yeah, I'll just not worry about it. Do it this way just so there's more consistency between. Okay. Yeah, I feel like radar is used for CTF challenges a lot, and so I get this impression that there's a certain amount of like it's been coded around that circumstance, whereas I don't think maybe an IDA or something would jump to a conclusion about a flag function because of the contents of the strings that are used within it. Or I could even be wrong and there is actually a flag symbol and I'm simply not getting it right somehow with Pwn tools, but shouldn't matter at this point. Okay, what did we do wrong? Oh, I need to pack this. Okay. So we got a seg fault. Can we see where we got the seg fault? Yeah, so E8, which is 232. So 132 minus, oops. Oh, god damn it. So let's see. I think the padding offset is 132. And then we need format. Okay. I'm going to let that go because it's just going to print an absurd amount, and maybe there's a better way to do this. Oh, maybe it's because we're interactive. I don't want it to be interactive. Let's do it that way. Oh boy, that seems, and it's still seg faulted. Okay, and we wrote 128 megabytes. My what do we want to do instead of? Okay, so we want to put a lot of spaces in there. A lot of zeros, doesn't really matter. But we need to write that address. Okay, let me double check why we got the seg fault. D message. Got a 1 in there this time. Interesting. What do we get? That is quite a lot. That's where the address is, I think. So, I don't know. And now we must be off in terms of where it is written to. We're just getting a 1 in there. Unless, let's run it in GDB, I guess. Put the pause here. Okay, we're in fgets. And we'll do it on the call to exit. Put a breakpoint there. Continue. Gonna do all of that writing. And then, okay. And what is at the D word pointer for, can we see what we wrote here? 84 A04. Or, yeah, 34. Okay. So that is what we've written to. If we look at the, we call it word, I think. And we have written the address of that function. So now we are here. Okay. And where are we getting the seg fault? The system call broken. Did we write to the system call incorrectly or something? I mean, did we like somehow override what is in the global offset table entry for system? I don't know. Run it again. Go into the, no, it called system. Okay. Did it print that information? Oh, well, it wouldn't print it in here because it's being consumed. Okay, so it's on exiting. So I think it's calling system. We need to maybe /n. Do that, and then yeah, okay. So we did have it. We just weren't printing out the flag. So cool. That ended up being a lot less painful than my brain was anticipating. From how I originally thought I had to do it, I was misremembering the mechanics that you use when you're exploiting a format string vulnerability. And then even when I realized what the mechanics were that would allow us to do it, my brain was still like, oh, this seems tedious. I don't want to do this, blah, 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 complaining. And then when I actually started doing it, it went pretty quickly. So obviously this is the first of this category. There's only 3 in here, so I'm not going to have to do too many of these. Hopefully, I think I will call this You know what? This went pretty quickly. Maybe I'll do the next one as well. I mean, why do a short stream when we've got so many of these to get through? I'm not going to read the walkthrough on this one. I think there might well be some improvements that could be made. What is going on? Why are they doing F flush instead of exit? That's fine. They're doing multiple pieces. So they are writing. Is that what is that symbol? It's a $sign. What is the $N? I saw that on the live overflow video as well. I guess I can make this a bit larger for those on the stream. So maybe I should review a little bit. Why are we using $N? They don't mention that at all. Interesting. But it does seem like maybe they are writing the address in single byte amounts? No. Why do they need to write to... Oh, yeah. They're skipping over one of the bytes, I guess, because maybe that byte is already what they need it to be. But... Oh, okay. That's probably smarter than what I went with, where I'm like writing... I'm going to have it write 128 megs of data. Maybe we can, real quick, improve... Okay, so we're going to write 1 byte at a time. Of course, at this point, the offset is going to be wrong. So just do a fixed 100. No, let's just do 0. Just feel like, what are the chances? I think that's fine, probably. Okay. And yeah, I just don't want that at all. For right now. Can I do it this way? Okay, so the idea here is we're going to write each of the bytes in the address separately so that none of our spacer format strings have to be gigantic. They'll be at most 256, so, you know, worst case scenario, we would be writing 1,000 characters or something rather than 128 million characters, roughly. Let's see where this ends up, what value that ends up putting in. Okay. breakpoint maybe? Okay. So, what do we have at x slash b zb? Put f6 there. Okay. Can this tell me what? No. All right. So if we put f6, then that's a good question. How do we do a like? How do I do a 1 byte write? Is that what the dollar sign is with the %n? Oh. Indicates the nth argument. Okay. Good to know. But how do we get this signed character pointer? So if we do an HH, okay. HHN will let us write a single byte, I think. Whereas, yeah, like what does it look like right now? Did that get written at all? Pretty unclear. Oh, no, because exit hasn't been called, so this is the value that it would go to do the initial stub. So we aren't writing to that address at this time. We are, where are we writing? I need to subtract 3 from this, I guess. Okay. Still hasn't been written to. So what did we write to? Just double check what that looks like. Why? Okay. I'm always getting tripped up by the not having the plus in there. I say always, but it's just been like twice. don't have the breakpoint. Still didn't write to it. What did we write to? Right to the next thing, which is 38. Yeah, okay. Okay. If we put like did it segfault? Doesn't seem like it's segfaulted. Interesting. And it didn't. So it's no longer in the right stack location. Oh, that one's segfaulted though. And that one we jumped to 3458. Okay, let's see what's going on with this then. If I run it and attach. Didn't write to that address. Okay. Where do we get the segfault? Don't know why we get the segfault. Nope, don't want to run it. So 4 bytes of values. We need we shouldn't actually need fewer %x's, right? Because the %x values are to move past the stuff on the stack prior to our string. So I don't understand why, yeah. We got an EOF. Okay, what was the segfault this time? Okay, so now we attempted to write to that address. So that is the right address. Let's start with that. Did not, it did segfault, but it still printed stuff. Maybe it did last time and I didn't notice. So we got 98, presumably 98 hex. Okay. So that's the amount that we need to worry about for the first one. Let's do flag adder and just get that low byte minus. Oh, okay. Yeah, that's. How do I. Okay, so if we do this, should be just writing 1 byte. And 804.8598, when the normal thing would be 804.85F6. So we just wrote the 98. Okay, good. Then what happens if we flow over the 256? So 98 hex, still need 660. Let's do like 150. And okay, so I think it's just going to write the low byte of whatever that number is. So we need to, how do we calculate this? Because we need to take 0b. That's what we end up needing to write. So we have so do this. Let's do it this way just to like get everything nice and even aligned and stuff. Okay, so the offset that we need to work with for the first padding is 98 hex. And we want flag adder we want to add a number to 98 hex such that modulo 256, the result is 0b. Obviously the smallest number. I'm gonna just ask a friend because I am terrible at math and I don't want to spend a lot of time on it right now. I mean, it shouldn't be a lot of time, but again, I am terrible at math. Okay, yeah, I mean, it's just simpler than I thought, I guess. So I need the low byte of the flag address plus I think that much. So quick. So let's say pad offset 0 is 98 hex. Flag adder is whatever. Let's see. Let 0 be in the low byte. Then I wanna add this. So we do 115. Okay. That, I mean, it's much simpler than, I don't know. I make these things more difficult on myself, I'm sure. Okay, so we can do that a few times. Or not like that, though. Oops, okay. So we're going to write each byte individually, but this one is going to be shifted over by 8, 16, 24. Do it this way. Oh, I don't want to do that. I'll just space it out. Don't want octal. Okay, and 1, 2, 3. Then the issue is we need to sort out the padding numbers for the other values. So we'll put zeros there and see what garbage we get. I've done something wrong. Have a parens issue maybe? No? What do I have going on that's incorrect here? Oh yeah, I do have a parens issue. Okay, segfault. And then should be writing 0b into that low address. I wonder if, whoop, oh, that's fun. Okay. This would be a good place for multiple cursors, perhaps. No. Okay. Let's go ahead and attach. And then before we call exit, we can look at what that memory has in it. We've just written a 3 in the low part because my padding must be off, I guess. Maybe I did something that impacts on the padding because 1, 2, 3, like adding spaces there or something. I don't know. I'm gonna start with, we need to add 11. No, we need to add 9 to this. Accurate. And then the amount is over. So, yeah, do we just want 9? Or, sorry, 9 plus 3 is B? Let's give it a shot. Why is it, what the fuck? Alright, let's attach. Now we've written 92. What the fuck? God damn it. How am I so bad at this? Okay, the flag address shifted over by 0 should be the same flag address. We mask off to get the low byte. So B plus 100 minus 100 hex minus whatever the padding is that we need. So it's not that, yeah, we do need to, we were getting too much maybe. Maybe I need to do 8F. We had to subtract rather than add. Okay, so now we're getting 10 there. 10 hex. Oops. So I'm gonna go back even more. I guess we just want A. Give that a shot. Why is that 12 now? Why did going back that much? Oh my god. I'm just making this like vastly more complicated than it needs to be, I guess. So let's start with this. Do 100. We'll forget about all of this stuff. Did not get a segfault there. Okay. So we'll have to attach. And did we write F4? I guess so. Let's double check that by, oh, I didn't mean to quit out of GDB. Putting this, oops, +1. So instead of writing it to the low byte, we will write it to the second to lowest byte. Oh, we didn't. Yep, so we write an F4. So F4, oh, that was my bad. I was making the same mistake that I just corrected somebody else on when I was asking for the math help of like 98 hex plus 2 is not 100 hex. Or plus, you know, or at least 98 hex plus 8 is also not 100 hex. So, okay. So if our padding in this situation is, and that's with 100. So we need to subtract 100 from that. What is 90? Okay. So let's say the padding is now 90. Can we try? See if that works. See if we write that 0b to the second to lowest byte. Yes, okay. So what I was thinking to do is write, just had some issues. Then we need to figure out what the padding here should be. Oh, hey Julian. Welcome back. So I was able to solve that challenge that we were left off on in the last stream. The issue with it was my call to the syscall to execve was not working, and the way that where is it in here? So this is the call to execve that we were running from the one gadget stuff. And when that failed, we get to here, and that's where the origin of the abort was. and this is in the like exec.com child function. And the issue was because this parameter has to be null. That's the sort of constraint that is presented by the OneGadget program. So if we look for because this is the arguments parameter and we're not setting up a correct array of strings arguments parameter, we are going to set it to null instead. So we needed RSP plus 70 hex to be null because we were using this one. And due to the alignment stuff that I had added into that second ROP chain to fix it to make sure it's on a 16-bit alignment, RSP plus 70 hex was no longer null. But by conveniently, plus 40 hex was null, so we were able to just use this gadget, and we were like basically so close to being done the last time. I just didn't have the time to do the research and figure out that's what was going on. So that was all good, and then finished that up at the beginning of this stream, and then I did this format strings challenge and got that going. And then for the past half hour to 45 minutes or so, I've been trying to fix it to be a slightly smarter way of doing this format string issue. The original exploit that I had was like writing the full 4-byte address to override a GOT entry. It was writing it as a single 4-byte write, which required me to output enough text with printf that the number was correct, and it was like printing out 128 megabytes of text, which is, just not the ideal way to go about it. So when I was browsing through their walkthrough, they were doing it in individual bytes. And so that's what I'm trying to do right now, is convert to just write each byte of the address separately, and then we just have to sort out like what is the amount of padding that we need in each of those, and that's where I'm at the moment. So yeah, we're gonna try that out. And should get the sig fault. Then what do we see in dmessage? I should probably just stick with didn't write anything. Is that accurate that we didn't write anything? Still 85. I wonder if can I change this to like 10 hex? And then nope. So we are not writing to where we should be writing. Because if we look at that, that should be the byte that we're writing to. So what is its problem? I guess I only need to write these lower 2 bytes actually. So I can get rid of this. But we still need to figure out how to write the 87 to that byte. Yesterday, after I closed the stream, watched 3 lives, and man, I mean, thank you for the compliment. I have no idea on that. All I can say is I'm trying to play this, and practice every day. This is both because I really like this stuff, it's really fun for me, and because uh, I'm kind of like ADHD or ADD rather. I'm not that hyperactive, but I find that I don't have a lot of routine in my life. And so trying to stick to something like every day I do this, I think is just helpful for me more on a personal life level, even than like, obviously there's the side benefit of getting better at this stuff. But yeah, well, I think a lot of my experience from it just comes from maybe having a couple decades worth of like practice programming experience and then having done software development. So some of the ideas maybe just sort of like click a bit faster than if you are first being introduced to them in these contexts. And so especially stuff like where you are having to mess around with the structures that are in place for things like linking, like the PLT and the GOT, um, learning about how linkers and loaders work, which isn't really that necessary for most software development, but if you can kind of come at it from the like developer side of where you are building this tool and the reasons why you build the tool, I think you get a certain amount more information that way, because if you're coming at it purely from a like here's a thing and here's how to take advantage of it, but you aren't learning why that thing exists and is structured the way it is, you aren't necessarily building connections about the structure of it and the concept of it that you could be if you were learning it from the like here's how we would make this thing standpoint. Yeah, my excuse is that I'm 16. I don't have that much. Yeah, I mean, being 16, like for sure. I think if you are able to follow along with this stuff and be able to do ponables of any sort at that age, I think you are doing a lot better than I did at 16. Um, I had done small amounts of like reverse engineering stuff around then, but certainly never done like a Stack Overflow exploit or any, I don't know that I had even really like, maybe I'd heard those terms, but really would have had no idea what was going on with that. It was just sort of like general, oh, there's some kind of hacking or something. Um, so I was a little more at that time just into like game hacking, where you're doing like a cheat engine and like modifying memory or trying to reverse engineer like a file format for a video game or something, um, along with programming stuff. So I'd say at your age you're in a good position, and if you just keep practicing, you're going to be like, I think, I mean, this is me just sort of like guessing, but I think if you find this stuff fun and you practice it, you're going to get better and better. And by the time you're in your early mid 30s like I am, you're going to be significantly ahead of where I'm at right now. So I'm not, no promises on like you're going to be world class or something. I don't know how that works, but the best you can do is just keep practicing, and then you'll get as good as you possibly could get. And I think that's how I try to look at it. Like, I don't know if I'll ever be good enough to go to a competition like Pwn to Own or certainly like DEF CON CTF or any of that stuff, but the if I don't practice as much as I can, then I won't get as good as I can, and I'll never find out if I could have done those things, I guess. So cool. I'm glad that you are interested in this stuff and you are learning about it, and that's always exciting to see folks at that kind of age are like digging into the low level stuff. I think especially even in the programming, even in the realm of people that want to do programming as young people, uh, there's less and less like emphasis on the low level stuff, which really reflects the software industry, where it's all just about like the speed of how much you can create, how much code you can output to generate a new project or a new feature or something as quickly as possible. So writing stuff in a language like C or even a Rust, if you are concerned about memory safety, like, is not the go-to for most companies, because it's just going to be a slower process. And so that disinterest in the low-level knowledge and techniques that covers a large percentage of the industry, not everybody for sure, but I think that then filters down into how it is taught. And like, if you look at stuff like the learn to code sort of initiatives and all of that, they're going to focus on a Python or something, which is perfectly, like, learn through whatever mechanism, right? But it's always exciting, I guess, to see somebody that is really interested in the lower level stuff, because it's always going to be there. And for me, it's just interesting to see the powers that you can get from knowing more of the trivia about that stuff and being able to turn that trivia into, in this case, exploits. But or figuring out how to defeat those exploits as well still requires a lot of that low level knowledge. So, cool. I'm glad that you are finding something useful in this channel, and hopefully we can keep, maybe collaborate on stuff in the future. Why is this? Do I need to put a spacer in between these two? I do need to put a spacer. Don't care about that then. That's probably what it is. Interesting. Oh, no, I don't want zeros. I can put... Okay, and then demessage. So now we are getting 07 in there. Interesting. Woke up just for me. Oh, okay, cool. So I guess this is like early in your time zone. So just get an 07. What am I doing wrong here? Nope, don't want to run it again. So we have, get rid of the other stuff on the stack, pull the first, and then, oh, this also gets rid of stuff on the stack. Then this uses the first address as the location to write a single byte to. This pulls another one thing from the stack. Uses this as not that early, fair enough. But I mean, especially if I don't know if school is still going on for y'all wherever you're at. But if not, then waking up 8:30, 8:40 in the morning when you don't have any any appointments, so to speak. I get it. I guess I didn't really wake up until around 9, so you're beating me on that count. Let's see. Again, this should be using that off of the stack. And this will be using the next address. What are we printing actually when I run it? So where is stuff being printed? We got /n. So we got all the spaces before this first value, but we don't need the /n there, do we? Okay. I don't know if that matters. I guess it doesn't matter, it's just that it's okay. Then so far that looks correct. And now we wrote 3E in 07. So why is it 07 now when it had been, oh, because I added 4 in here, right? So then our offset needs to go back by 4. Do we need that? Let's double check if that works. Yeah, okay. Then with 0x50, let's put 0 in there. See if that helps me calculate the number that I need a little better. So then we have 92, and we want what do we want? 87. So we need to loop around by what? 8 and 3, so another 11. So we need to be 11 less than 100 hex, which is maybe that. See what that looks like. Nine C. Let me go from 9.2 to 9C. Overshot somehow. Oops. Now we're at A2. Why is it going up as I... Oh, I guess it... I mean, it makes sense that it might go up as I lower this. But then... Like if we do... FF, that's going to give us an add of 1. I don't think that's going to get us where we need to be. So now we're at 9.3. Oh, right. As we go up, we need to okay. So 9.2 . difference. Apologies for my terrible math skills. What? Okay, 92 was the value that we were seeing when we added a padding of, when we had a padding value of 0 with our code to compensate for the padding value. So maybe that's all we need. No, that brings us to 0, 0. So then we need to go back from there to get to, so, oh, maybe, no, I don't think this would work. What, 0, B? Oh yeah, that was it. Okay. Well. And then we can okay, cool. So basically just put the address of the first byte in that 4-byte sequence, then the second byte in it, the second to lowest valued byte in this address, or not this address, but the GOT address. And we overwrote just those 2 low bytes because the 08, 04 were the same between them. If we had to repeat this process, we could just do it for the other 2 bytes as well. And then it was a lot of futzing around on my part to do various, like, I'm probably making it more complicated than it needs to be, but I'm just trying to work out exactly what value, how much space we need to print out so that the end value prints 0B into this first one and then 87 into the second one. The 0B was why I ended up with this trickiness, because we are already well past 11 bytes worth of stuff, having printed out all of this. And so we need to get a value that when it is modulo 256 is 0B. So we basically need to get to 10B hex, which, what, 267 bytes? Yeah. And then same deal for this one, but we need to get 87 instead. And that only required us to write an additional 11 bytes. I think the fact that this is 0B and this is 0B is just coincidence. I don't know. Cool. So, and then it doesn't print out, doesn't use printf to print out an absurd amount of stuff. And certainly, like, it's the original approach that I took is doable with a 32-bit address. If this was a 64-bit binary, me trying to write enough spaces that the %n wrote an entire quad word or even 7 bytes worth of data would be, just impossible would be my guess. Like, I don't know how many gigabytes worth of printing that would require. So that approach is completely out the window. And I'm glad that I went through the walkthrough and saw, oh yeah, you can just do it in individual byte components. Maybe I would have come to that conclusion if the next challenge is a 64-bit one. Don't know. We'll find out, I guess. Okay, so we'll just go into this next one, and then I think me rewriting the backdoor, the BB pwn one, took long enough that I'm just going to do echo and then probably call it an end for this session. In light of the fact that Julian, you you are my most interested person watching the stream. Few other people have come in and talked a little bit, but they didn't seem that knowledgeable about Pwn stuff, so they were not necessarily like getting a lot out of it or interacting much. I think I'll try to do my streams a little bit later so that it's not like, oh, just wake up at like 6 a.m. if you want to watch me get started, rather than I start now and then end right around the time that you are able to join in. But I do have a pretty regular commitment at a couple hours from now every day, so I can't go too late. But I'll try to push the start a little bit, to maybe. It'll probably be like 7 a.m. your time, unfortunately, but that's the reality of the time zones. Oh, you've done this one? Okay. Well, let's see how quickly we can get through it. It's been going for almost 3 hours now. I guess I just need this one. And I can quit out of that. I should really do more of the Pico stuff. Pico CTF. I know that's going on right now. If you want to learn about Pwn stuff, I have a good recommendation actually, in case you haven't watched his streams before. I don't know that he streams on Twitch, but he streams on YouTube, and that's just as easy. Let me get this run real quick. And I was watching some of them. I was, for a different thing, I was needing to learn about Windybug, and he had a stream where he was like messing around with Windybug, and that reminded me. But this guy, Ginvale, I think, Ginvale, I don't know how it's pronounced. He's going through Pico CTF right now. That's what reminded me of it. Presumably the 2020 Pico CTF stuff, and he's a really good sort of hacker in general, Pwn kind of guy. He was a competitor with Dragon Sector, which is a big. He's Polish. I think that's their big Polish team. That's done. They've certainly been to like DEF CON CTF and are up there, in terms of their skill set. And he doesn't actually compete with them anymore. He's more like a maybe coach manager kind of role at this point. Oh, okay, you know of him. Yeah, so I mean, obviously, okay, maybe Pico CTF stuff is a little too easy. Yeah, do the nightmare stuff. I mean, they range from pretty easy to, definitely took me some serious effort on some of these, and a little bit of it is like I've never done ROP before, so when I started having to do that, it got complicated, or at least got more difficult. And I don't know. There's definitely a full range of like the DEF CON qualifiers one, the Feed Me one at least, was, and the Simple Calc one. I think I made Simple Calc more complicated than it needed to be, but that's simply how it goes sometimes when you don't know what the intended solution is. You come up with a solution that turns out to be more annoying to get working than it had to be, I guess. But yeah, or just pop into the heap stuff, like totally, it's just a big collection of stuff, right? So the nice thing is, unlike maybe Pwnables.kr and some of the other big collections of stuff, which I haven't looked through enough, so maybe they do have it organized well, but they might not tell you what the kind of exploit you're looking to do is. Whereas this, these are all going to be heap kind of challenges, so there's that benefit. But yeah, I would suggest go through it, keep practicing. And eventually, given how long these are taking me, looking at 2-3 weeks maybe, I'll get into the heap stuff. That would be great if I can keep this up on a daily basis. Okay, so we've got echo. Just going to go through the usual stuff. 32-bit, dynamically linked, not stripped. Okay. And no canary. Ooh, not that that would matter in this case. I think no PIE is helpful. So then if we run it, okay. Need to throw a flag in. And let's look at, okay, so they're just going to pass it to, yep, there we go. How many before we get into our data? It's quite a few thus far. Interesting. Doing this the slow way of manually typing stuff in and mistyping stuff. Okay, so after some number of entries, we get to our, so it's this, right? Copy this out. Ten entries, I guess. It's a little, I don't know how to do that in Python, so I just pop it into Ruby, but count the number of x's, since they're all going to be printed as 0x whatever. So you should be able to do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then %n should try to write to this bogus address. Yeah. And then dmessage, we tried to write to that. Okay. Cool. So we know where we can do whatever we need to do. And let's see what we have available. The other one had a flag function that we could just pop into. This one, oh, maybe because we had an exit call, we didn't have a return from main in that earlier challenge. Oh, that's possibly, let's look at main. Okay, and that'll call exit if we go down that path. Otherwise it loops forever. Okay, interesting. So there's again no return here. But, oh, this one we just probably, because it's going to read the flag into memory with fopen, and where do we put it? At 90? Yeah, so then fgets is going to read that flag into presumably this address at 4ch. So EBP minus 4c, right? And where do we get, where do we print the it's more like a fuzz challenge. This echo one, I guess I'm not sure what you mean by fuzz challenge, just in terms of like just try fuzzing it with like format string stuff, and eventually one of them is going to print out a flag, and you wouldn't even really need to go through and come up with what the exact input should be. Is that, because that would be, I'll keep that in mind if that's what you're trying to say, for when I want to start practicing with fuzzers, because I've done nothing with fuzzing. I understand the concept, but I've never actually installed AFL or, done anything with it. So having some like basic ones that, yeah, I mean, just throw, like, this would allow me to test my ability to set up a fuzzing sort of harness, or whatever the right term is, and say, use this kind of mutation, right? Don't randomly mutate bits, but generate strings in this grammar, and then look for this in the result rather than a crash. Maybe look for a flag curly braces thing printed out. That'd be neat, because that's a little bit different than maybe the bog standard setup of like mutate random bits and then see if you get a crash. You can do it in Bash pretty easy, or Python. Yeah, I don't think you would need a full like tooling for fuzzing setup for this. And maybe if I do this one the manual way, and then also get through the next format string one, before we move on to array indexing, I'll take some time and try to do it with a fuzzer for the echo challenge. Just write a little fuzz script for that. That would be pretty neat. Okay. But I think for right now, I'm going to continue on the sort of like manual process and see if I can work it out through this. So we call fgets and put that into what are we printing out here? Oh, that's just the prompt. All right. And then it echoes that with printf. So that goes in 8C and 4C. So this is the address I have there, right? Let me think. No. 4C is the buffer for that. So if we are getting to that stuff after, how many was it? 10 prints? Or after 9, I guess. We're moving up the stack, right? We just need another 16. Python print say 25 plus %s. Okay. I don't know what I need to do with these programs where if you give it end of input, it just loops forever. That does a null. Maybe I need 6. Nope. Okay. It's trying to dereference the wrong thing. Also null. I still one too far. This is all 78, 25. We have A0. Let's do. What was I doing before? 25. A segfault from that. Interesting. Okay. So we're still short. Try 28. Let's see, I'm just gonna. This is just gonna be my process of like try a few more. Oh, that was enough. Okay, there we go. Apparently it takes 28% Fs or percent Ps, so we could do that. Make it a little simpler. Didn't work that time though. Interesting. Because this is, but it should be at a fixed location. So doing, let me try another one. See if that impacts on it. No, I think we need to go back one. Or two? No, interesting. Because like, this is all our buffer. And then what do we have? I don't know, some number. I need to do it as like percent %P because otherwise I can't see the, I can't tell the spacing between them. I could do this. Let's say. Okay. Where were we at when we got the, this 27? We've got up through, what, 1, 2, 3, 4, 5. So we need 2 more maybe? Or maybe it is 28. Maybe, I don't. Now I feel like I need to do more work because I am not seeing the behavior that I anticipate if I take out the pipes. If I take out the separator characters, why is accessing a particular fixed location in the stack frame different? Because it's just going to read into that buffer, and I think the fgets call is, you know, it's not going to overflow that buffer. So I don't think it's overflowing the buffer. Yeah. So it works with the pipes, but if I take the pipes out, it stops working? Oh, yeah. I saw that when I was looking up some... Okay, let's try it that way then. I think it is like $28p. And then, well, there... I don't need Python for that, really. Percent $28p, percent %s. Okay. All right. Let's see. There was. Okay. The last. Yeah, the last 3 bytes. So, okay. Where were we trying to read? Trying to read at 40 now? So we're like. Oops. Without the S? Okay. Yeah. And then let's do that with the pipes one, just so that I can compare against the memory that I was like, oh, Jesus Christ. Okay. Then if we run echo, so we were seeing the 7. Not sure which one that is. And then A7, D7, 4. Just trying to like line it up with what we're seeing here on the stack. Did I do 30? Not yet. It's F7D, A9. Is it any of these? Don't think so. 48. No. And all zeros, huh? Oops. So I feel like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Yeah, sorry. So it should be 29. But no. Is that value, and that's not. We could try the Yeah. This one is like, I don't understand what I'm causing to work differently with the pipes in there. Because it's not. So we do like %10, %11. Right, is that see the A70 anywhere? Okay, so far so good. So then say 1, 2, 3, 4, 5, 6, 7, 8. We want something probably ending with 75C. No, we got something ending with C3C, which is just not in here. Okay, but if that's 8, 9, 10, 11, 11 is where we should start reading into our the buffer of the string, of the like format string itself. But we aren't seeing that happen. Oh, well, that's partly because, no, because this should be like the beginning of the format string, right? So maybe this is what that is. It's 1, 1. Okay. Yeah. %11 dollar, and then 70 as P, I guess. And then A for new line. Okay, so that is reading into the buffer, and it's all nils after that until, what do we get, like, okay, so $27S. No. Even though, oh, I guess there are 1, 2, 3, 4, 5, 6, 7 things after. So percent 33. Maybe because it is. Shouldn't be due to some kind of misalignment. But I guess it is due to some kind of misalignment. Maybe. Those are the same. And that's back to being nil. Oh. Is that... So when you do %s, it's going to take a value from the stack and treat it as a pointer to the string that it will then print. The string that we want to print is already on the stack. Like the buffer for it is on the stack at 4C, EBP minus 4C. So if we start trying to print that if we do a %s at that location, it will try to use the contents of the string as the pointer, which is going to segfault. Presumably. I mean, I guess in theory it doesn't have to, but how am I getting it right here then? Why is it working in this case? There must be, we must have pushed that pointer to somewhere. Oh, because we, yeah. We load it in and then we push it to the stack because that's the calling convention that we're using. So the pointer is on there somewhere, presumably at this point. So somewhere in here is the text of the flag. I would think. %27p. Right, this is the flag text right here. This is like LA or FLAG. And so I don't know, I didn't see that in any of this. I guess it's what this is, but I don't understand why it comes out like this. That was something that I was curious about, but didn't vocalize my curiosity on that. Why does that happen to be a pointer to a string? That seems unlikely, right? I guess they could, they built the binary, they could have chosen to do that. No, but that's segfaults. So yeah, I don't know how amongst all of these, like just printing out hexadecimal, you get a the greater than symbol. If you can think of a reason why that would be, let me know, because I didn't put a greater than symbol anywhere in my input text. And this is the only %s, and it's doing the printing of the flag there. So after the space for the flag, which is another 40 hex, I guess. So we do %27p, %28p. That's going to be TEST, I guess. And then that's the other T, closing curly brace. TEST, curly brace, end line. Or, yeah, new line. Okay, and then, so I'm really curious that I guess we have gibberish in there. That's fair. Yeah, I mean, I sort of go back and forth between that approach and this sort of like spending a lot of time trying to understand it. But basically, what I tell myself in the times when I'm like I want to spend time understanding this is if I do the legwork of really trying to understand exactly why it's working the way it's working or not working in some other way that I thought would work, even though I was able to get the flag at some point, it's not something that I would do in the middle of the CTF, obviously, because under a time constraint, it's just not worth it. But putting in that time to really understand, like, oh, it didn't work that time because of X reason or something, I feel like does give me a better basis for being able to reason about a more complicated situation, I guess. That is my hope. That's certainly what I tell myself when I am spending time on something like this, where it's like, I've gotten the flag already, so why am I continuing to dig into the details of it? But this, yeah, I'm sort of approaching my patience level on this one, and I'll have to put it in the list of stuff to maybe eventually get around to understanding a little bit better. On some level, it's just like the details of the printf function, and is it really worth all of that? I don't know. I don't think that, outside of CTF challenges, my exploit work is, if I'm trying to get some CVEs or something, I don't think the vulnerability research is really going to hinge on being able to successfully exploit a printf vulnerability. Those don't seem to come up that much in what I can tell. Other than before you joined, I was talking about, you might want to go back and look at the beginning of this stream. There was a podcast episode that talked about a bug in the Mazda infotainment system, which turned out to be like a printf type bug, and I went into some detail about how that works. I'll throw it in here, and there's a link. Do I link to it? It's in the... Okay, I don't think I linked to the reply all episode, but I'll get you that episode as well, because it's a fun listen if you haven't happened across this before. They get a call from somebody whose car seems to crash when they try to play. I mean, the car itself doesn't crash, but the infotainment system sort of they don't know quite how to explain it in the right terms, but basically it's crashing and then rebooting automatically. And it's whenever they try to play this particular podcast. And so I did some work on it, figured out it was a printf vulnerability. I even was able to, somebody on Twitter posted like links to the firmware upgrade files that you could download, and I dug through those and was able to identify what was most likely the binary that was causing it. It was only happening over Bluetooth, and they had a native binary that took in the Bluetooth data and converted it to JSON and sent it over WebSocket to the web interface that the infotainment system used. And so in the process of converting some text to put into the JSON structure, they were eventually calling printf on a string where they had already inserted some text from the user, or in this case from the podcast app that was talking to it over Bluetooth. So they were calling printf on the thing that had the percent format specifier in there. And I guess in theory I could work on that as a CVE, like how do I get this to crash? But also in the episode they said that it had been fixed in more recent versions, so I don't know if I'm ever going to put the time in. Of course they may not have really fixed it, they might just be saying that, but that's the only time I've seen a real world case where like a printf thing is in any recent time frame has been an issue, let's say. So I don't know. I think I'm gonna call it here for this stream, and I will get into the greeting one from Tokyo Western's CTF 2016, and then maybe follow up with quick trying to do a fuzzer on this, because I think it'll be fun to try to think about how do I construct the right format strings. I mean, the problem is I know what the solution is for this one at this point, so a very quick fuzzer that I can write right now would be like, let's say I guess, yeah, let's just open up the process. I'll do the fuzzer right now, why not? But the problem is, like, I kind of know what the format structure should be, so this is going to be a very targeted fuzzer and not maybe what I would have written if I didn't. I don't know. Because even if I didn't know exactly what worked, the approach is still kind of the same. So let's do while true, and we will say target.receive until the prompt, and then we will a case plus equals %x. In this case, I'm going to do it with the pipe because that seemed to be necessary for my thing to work. And we'll say case plus %s. And then what do we want from lib? We want like receive contains. Receive line contains I guess we'll just receive one line, and if it happens to contain, so. Think we can write it this way? Or print res, let's say. Okay. No. Maybe. Oh, it's like. Okay. Need to actually import Pwn Tools. Okay, and think that'll work. No. Did it segfault? Oh, okay, yeah. Let's see. What is the syntax? Try accept, maybe? Okay. Just like, okay. There we go. The fuzzer worked. I mean, I knew it would work because we had done the stuff for that before, although it's much shorter this time. That's interesting. I don't know what that's about. But maybe I don't need the, like, pipes. Let's try without the pipes. Now that we've got a fuzzer, we can just run it real quick. Yeah, so whatever. I guess the pipes approach for some reason only works, or is the only way that it works if I'm going like beyond the. You know what's probably happening? I was probably going beyond this function's stack frame and going into the stack frame that printf had left behind. Or maybe fgets is left behind, but like one of the leftovers of a previous function calls stack frame, which happened to have a pointer to, they had pushed that pointer on the stack at some point or whatever. So because the pointer that we need to be getting is way earlier than our own buffer of the printf input that we are giving to the program. So, and this is more reliable, I would say. So we could try it with a number. So we'll start it at 1, and then we'll do and no, that's not See if that works. Printf format string and try use it manually. Oh, I see what you're saying. Okay. Let me save this as fuzzer2 and then go back to what I had that was working, and that works. Then first print out the case basically plus the %s. So we get this working, right? And it's much shorter than the ones that we were working on. And it still works. Is that what you were suggesting? You see me now? You see me now? Is that sort of what that's... Okay, now fuzzer2, rather than create a case where we have a bunch of %x's, we're just going to try to do the parameter reordering stuff by putting a particular number in, and we will just keep increasing that number, and we'll try everything as a %s. And we might as well also, so we could do like okay, then let's see if that works as well. And it did. So if we do %8$s, that'll print out the flag. Cool. And that's a little bit a little nicer to read than, what am I saying? Than the one that has all the gibberish from the %x's. So yeah, cool. I think I am glad that I spent a little more time on this one, worked on the fuzzer approach. I think that is simple enough that like I'll just try it for the next one. Might as well, right? Maybe I can get the fuzzer going for this other challenge as well, the greeting one. And if that's the case, then I don't know, just like keep doing fuzzer stuff. But I guess it stops being as easy when you are doing a %n kind of thing and you need to write data somewhere rather than just read info off of the stack. But I could use this if I needed to use a printf kind of vulnerability to leak info to then later use in some other stage of the exploit. So cool. And I feel confident that our ability to print out that string when we had a much higher number than 8, like I think it was like 27, 28 or so, just as %x pipe stuff, was purely because we were accessing it from the old stack frame from printf or something, and it just wasn't put in that location or was otherwise not the same when we didn't have the pipes in it because of however printf was processing our format string that we passed in. So that certainly that approach is a much more fragile one and should have just tried the fuzzer to begin with, because we would have found this really quickly. All right, I think that's it for me for this stream. Thank you all for joining me. Whoever's in chat, you see me now, and Julian, and whoever is just watching the stream and enjoying it silently. I appreciate your presence and your hope that you get something out of this. I didn't do this on the last stream because I was running out of time, but I will throw up my website, which really right now is still just redirecting to my GitHub page. If you want to check out, I don't know, the couple of things that I have on there, there's not really a lot that I've been doing lately, and a bunch of these, this is like a project where I was following through on a book, and I don't even remember what I've committed here, but a lot of the projects are from when I worked at a coding school, and so I worked on projects that the students would work on. I would create the projects and stuff like that. So don't have any really interesting projects of my own at this point, but I have some plans. Maybe eventually I'll get there. And if you want to reach out to me on Twitter, twitter.com/hamledonline is the way to do that. HAMLED online. I do tweet, like, it's a lot of stuff about politics in the US, and significantly less stuff about tech, but certainly if you want to talk about tech stuff, I'm happy to talk about that on Twitter. If you want to follow me, I'll try to follow you back. Just have to find somebody in my list of thousands of accounts that I'm following to get rid of, and then I'll free up some space and be able to follow you. Yeah, appreciate everybody, and or I am going to end the stream now because OBS has crashed. So I'm sure that was a little bit disruptive on the viewing side. All right, adios, everybody.